Welcome to video 1 of 2. This lesson will be set in 2 videos because it's actually 2 different presentations. So you'll get the first video and the second video, and your job is to watch both, fill in the notes, and then answer the guided questions, as always. So the first lesson is an introduction to a chemistry topic, which is quite large, and we're actually just going to skim the surface of it so that we have enough of the information needed to do the AP Bio stuff. But this topic is a huge topic in chemistry, and one that we didn't get to last year, and then one of the reasons why I would have to do some learning again if I was to teach AP Chem. So, the topic is called oxidation reduction reactions, and the abbreviation for oxidation reduction reaction is redox reactions. In oxidation and reduction reactions, 2 things happen. One of the reactants in the reaction loses electrons, okay, and that is called oxidation. Okay, in biology, we're going to see this as a loss of hydrogen. If you think about hydrogen, just for a second, okay, so hydrogen has an atomic number of 1 and a mass of about 1. It's like 1.08. So if you calculate the protons, electrons, and neutrons of hydrogen, the protons are 1, the electrons are 1, and the neutrons are 0. Okay? So essentially hydrogen is composed of 1 proton and 1 electron. In reactions, when reactants either lose electrons or lose hydrogen, okay, they're considered to be oxidized. I'll write that. Or that an oxidation has occurred. In the same reaction, if something is oxidized, something else must be reduced, okay? And things that are reduced either gain electrons or gain hydrogen, okay? Now, in all chemistry textbooks, this is not something that I made up, there's a way to remember this, and the sentence is Leo goes ger, okay? Loss of electrons, oxidation, gain of electrons, reduction. You will see that in almost every chemistry textbook as a way to remember when things lose electrons or lose hydrogen, it's oxidation. And when things gain electrons or gain hydrogen, it's reduction. So, if we take a look at this reaction, okay, this is actually of the reactions that we learned in chem, this is actually a combustion reaction, okay? In this reaction, this is methane, this here is methane. Methane is becoming carbon dioxide, and oxygen is becoming water. So if we look at what was oxidized and reduced in this reaction, methane became this, right? It lost its hydrogens, like it was CH4, and it became CO2. It lost these 4 hydrogens. So it, okay, was oxidized. Okay? Now, where did those hydrogens go? Okay? They went to oxygen, and oxygen became water, and these hydrogens here were from the methane. So oxygen here was reduced. It gained hydrogens and became water. So just to summarize, methane, this guy here, was oxidized because it lost all its hydrogens. It became carbon dioxide, this guy here, okay, which has no more hydrogens. And then oxygen, okay, this was what was reduced. And it was reduced to, over here, water, because it took the hydrogens from methane. Okay, now on the bottom is some vocabulary. The AP exam used to use this heavily. When they changed the curriculum, they didn't really use it anymore. But the thing that is oxidized, which in this case was methane here, is called the reducing agent. Okay? Because it's like helping this be reduced. This guy here is helping oxygen be reduced. Whereas the thing that is reduced, okay, is called the oxidizing agent, because it's helping the methane be oxidized. Okay? But in general, the vocabulary, the AP exam doesn't use that vocabulary anymore, but chemistry AP exam would. But that vocabulary is not really used much in AP Bio. I'm trying to make, I can make this full screen. I didn't know that. Anyway, there we go. So, what I would want you to do now is pause the video and see if you can figure out in this reaction who's being oxidized and who's being reduced. And then I'm going to explain it, so that's what I would do if I was watching this. But, so pause it now, and then, okay, now that we're back after you've paused it, in this reaction you'll see that this guy, which I'm not going to give you its name, okay, he's becoming carbon dioxide. Alright? Notice he had 12 hydrogens, okay, and it became carbon dioxide. Carbon dioxide has no hydrogens. So this was a loss of electrons, or an oxidation. Loss of electrons, or an oxidation. And then oxygen became water. Okay, this had no hydrogens. It now has 2, and there are 6 of them. That's a total of 12. So, this is a reduction. Because this lost electrons. I'm sorry, well, this gained electrons. My bad. This gained electrons and became water. So in this reaction, this guy here was oxidized because it lost all its hydrogens. And this guy here was reduced to water. So if we look at this slide, we'll see many different carbon molecules, and it's asking a question, which is the most oxidized carbon molecule? Okay, in this case, the most oxidized carbon molecule is this one. This one lost all its hydrogens. It has absolutely no hydrogens. Okay, so it is the most oxidized carbon molecule. There are no hydrogens attached to it. It lost all its hydrogens. And we would actually call this one the most reduced, because it has the most hydrogens compared to this one, but don't worry, that's more complex. But remember, oxidizing means losing electrons. So things that are oxidized in reactions have lost electrons, or hydrogen. And things that have gained hydrogens or electrons have been reduced. Okay. So, on this board is the reaction for respiration. Okay. This is glucose. This is our good friend glucose. This is our good friend oxygen. Okay. This is our good friend water. This is our good friend carbon dioxide. And this is our good friend ATP, or energy. So if you look at what it says on the bottom, it says respiration is the complete oxidation of glucose to carbon dioxide by oxygen. Okay? So when we say the mitochondria is the powerhouse of the cell, that is completely wrong. Okay? The mitochondria is where respiration occurs. And respiration is the complete oxidation of glucose to carbon dioxide by oxygen. So if we take a look at this reaction, glucose has 12 hydrogens. It loses all those hydrogens, okay, and becomes carbon dioxide. Okay? Who took those hydrogens? Oxygen took those hydrogens. And when oxygen took those hydrogens, it was reduced to water. Okay? So in respiration, oxygen takes electrons from glucose and becomes water. Okay? Now, while we do that, okay, while we do this oxidation of glucose, we produce some ATP. Okay? Or energy is released as you're doing these oxidation steps. The oxidation steps are complicated and very complex. We're about to look at them next week. For now, until Monday, it is enough to know that respiration, okay, is the complete oxidation of glucose, this guy, to carbon dioxide, and oxygen is the thing that takes the electrons. Okay, it's a little bit more complicated than that. We're going to see next week, but for now, that's good enough. One more thing I will say is that it's important that you have this reaction memorized. This should be like the ABCs. You should say in your head, oh, respiration uses glucose and oxygen and makes water, carbon dioxide, and energy. That should be on the tip of your tongue. It has to be. Alright, otherwise you will be ultimately confused. Alright? Answer the guided questions for this video and then you'll get the next video as well.